Hey guys, so you probably cannot see me, but that is okay. I just want you to be able to look up here today because we will be going back and forth with Desmos. So today we're going to be comparing linear graphs, exponential graphs, and quadratic graphs. And one of the biggest questions that the EOC likes to ask you is which one best models the data. So that's what we're going to do today. So please, I know it's going to be a lot of notes, but it's very, very important that you copy this down and you know the content. Okay, if you don't, please email me. Please come to my Google Meets. Okay, because it is important. Okay, so to start off with, we're going to make a graph. Okay, so make a graph like mine, if I can zoom out. There we go. Okay, so you want 3 by 3. Okay, so you want 3 columns and 1 in the middle. Okay, so the first one that's very familiar is a linear graph. Okay, the equation to a linear graph is y equals mx plus b. And it's going to give you that straight line. Okay? So, if I ask you, okay, using these points, what kind of graph does that give you? Where if I go to Desmos, okay, go to Desmos, I can put those values in here, okay? So I'm going to come to create a table, and my x values I'm going to put on the left-hand side, so -1, 0, 1, and 3. Over here I'm going to do -2, -1, 0, and 2. So if I ask you, okay, if I give you a set of points and ask you what kind of model best represents this data, okay, you can see how it is a straight line. Okay, since it's a straight line, it's going to be a linear function. So some questions might give you a list of points, and you're going to have to graph them to be able to see what kind of shape they give you. Okay? The next kind is a quadratic. Okay, the general equation for a quadratic, and you may need to pause the video to make sure you get all this information, okay, is y equals ax squared plus bx plus c, and you're going to have that U shape. You're going to either have a smiley face or you're going to have a sad face, okay? Again, if I give you a list of points and tell me which model does these points best represent, okay, you're going to need to graph them in Desmos. So we're going to go back to Desmos, and we're going to graph them. So again, I'm going to go to this plus, go to table, put my x values on the left-hand side, and you will have access to Desmos on the EOC. And if it's on the inactive, then you're just graphing by hand. But it's quicker if you use Desmos and more accurate. Okay. So just looking at this, if I were to trace these, okay, and if I would have connected the dots perfectly, it would give me that U. So is this linear or is it quadratic? It's quadratic because it's in that U shape. Okay. So again, just being able to graph these points and telling me which model, okay, it represents is going to get you a long ways. So you just have 3 different models you have to worry about, and that's linear, which is a straight line, quadratic is a U, and then the last one you have to worry about is exponential. And you do need to memorize the formula too. So the equation to an exponential function is y equals a times b to the x. Okay? And you're going to have it kind of looking like this. It's not a U shape, but it's not a straight line either. It's a little curve. Okay? So let's plug these in and see what kind of shape it gives us. So again, go here, get a table, put in your x values. And put in your r values. Okay, and you can kind of see that this is going to be an exponential one. So again, if I were to trace these, okay, it's exponential. Okay. So that's the first kind of problem you can see. They're going to give you points, and you have to tell me if it's quadratic, which is a U, exponential, which is a curve, or linear, which is a straight line. And Desmos will give you that easily. The next kind of problem is if they give you a table of values and you do not have Desmos, okay? Because we know if you have Desmos, you can just plug this in and tell me like we did up here. However, sometimes it's not going to be where you can use Desmos. It's not going to be on the calculator active. And you're going to need to know how to do it by hand. Okay, so if I look at this table, a linear table, okay, the characteristics of a linear table is it's constant. Okay, you're going to either increase or decrease by the same number. Okay, so both sides are constant, so that means if I take the difference, to get to -2 to -1, I have to add 1. -1 to 0, 1. 0 to 1, 1. Okay, if I go to my y, -1 to 2 is +3, 2 to 5 is 3, 5 to 8 is 3. Okay, they're all the same, they're constant. Since both sides are constant, it's going to be linear. Okay, so if you add and subtract by the same number, it is linear. Quadratic is a little different. Okay, so the first thing you need to do is you need to find a difference on your x-axis. Okay, they all increase by 1. Cool. But if I look over here, 1 to -1 is -2. 1 to 1 is +2. 1 to 7 is +6. 7 to 17 is +10. Okay, they're all over the place. Okay, if they're all over the place and you don't have the same number, you need to take the difference from the differences. So you have to do the second differences. So from -2 to +2, it's 4. 2 to 6 is 4. 6 to 10 is 4. If your second differences are all the same or constant, then it's quadratic. Okay. So if you're doing these and you notice that you're getting different numbers, take it again, okay? And if they're the same, then you know it's going to be quadratic. Exponential is, I think, is the easiest. If you're multiplying or dividing by a common ratio, okay, you're no longer adding and subtracting like with linear and quadratic. You're multiplying or dividing, it is going to be exponential, okay? So if you look, so to find the ratio, I'm going to take 0.5 divided by 0.25 and I get 2. Because 2 times 0.25 is 5. 5 times 2 is 1. 1 times 2 is 2. So I have a common ratio, so therefore it's going to be exponential. Okay? So it's only exponential if you're multiplying and dividing by a ratio. And that completes the table. So I want you to use this table that you have written down, and I want you to try these 2 problems. Okay, try problems 1 and 2. So go ahead and pause the video if you haven't already and complete those 2 problems. Welcome back. So for this one, I'm just going to do the Desmos and I'm going to graph. Okay, go to table. put in my x values. Then put in my y values. Okay, so looking at this graph, what kind of graph do you think this is going to be? It has a curve to it. Okay, it's going to be exponential. So that is the answer to number 1. Okay? The exponential model is the best. Okay? Let's look at the second one. Again, I could use Desmos, but we have to know how to do it without using Desmos. Okay? So I look from here to here, I have negative 0.25, I subtract. Here to here, minus 0.25. Here to here, minus 0.25. And then from here to here, excuse me, what am I doing? Okay, minus 0.75, minus 1.25, and then minus 1.75, okay? These are all different values, okay? And again, to find these, I'll just take my second one, subtract it, see what my difference is, okay? These are all different, okay? So it's not linear, okay? Exponential, I'm not multiplying anything, so it might be quadratic. Now, we can't just say it's quadratic, we need to prove it is. So we're going to have to take the second difference and see if the second difference is constant. Okay, so from here to here, I minus 0.5. Here to here, I minus 0.0. From here to here, I minus 0.5. Okay, these are the same, and this is the second difference. So therefore, it is quadratic. And that's how you would do a table. So those are two different kinds of problems. Now, a more realistic problem that you're probably going to see on the EOC is similar to example 2. Okay? So let's look at example 2 together. And yes, I would copy everything you see here. The data gives the value of a used car over time. Which type of function best models the data? And secondly, write an equation to model the data. Okay? So the first thing I'm going to do is I'm going to find the differences. Okay? So let's do 12, 575 minus 11, 065. Okay? So I get 1510. And let's try this 11065 minus 9750. Okay, I get something completely different. Let's just see if I'm multiplying by anything. Okay, so let's do 12, 575 divided by 11, 065. Right, 11.65 divided by 12,575. I get 0.88. Okay, so again, you're going to take your second number, divide by the first. I get 0.88. Okay, so let's try the next one. 9750 divided by 11, 065. 0.88 again. So I'm multiplying by 0.88. Okay, if I take 9750 times 0.88, I'll get my next one. Okay, and then if I take that and times it 0.88, I'll get this next one. So I have a common ratio, so it's going to be exponential. So the formula for exponential is y equals a times b x. Okay, so you're going to let a equal the initial value. Okay, if you look over here, my initial value at 0, what I started off with is 12,575. Okay, let b equal your ratio, which is 0.88. So if I were to write it, y equals, plug in my values, to the x. Okay, so that would be my equation. Sorry, I almost dropped my laptop. Okay, so it would be exponential, and this would be my equation. Okay. So that's how you would do that one. And you could have also graphed these values and see that it was exponential, but you would still have to find your common ratio for it. I want you to do this one on your own. Pause the video, okay? When you do these kind of problems, if you're given a table, find if it's a common difference, okay? If it's multiplied, find the ratio, okay? And then whatever model that you pick that best represents this, find that information to plug into the equation, okay? I want to give you a hint, okay? You may want to use Desmos on this one. Welcome back. Okay. So for this one, we're going to use Desmos. So I'm going to go to Desmos. I'm going to come here. And I'm going to create my table. Years are going to go in my X, income's going to go in my Y. So step one is to see what kind of model best represents this. And you have to make sure you put in the values correctly. So if your screen looks like mine, you don't see any dots. So that probably means you need to zoom out. And you probably need to go up until you find it. So keep zooming out until you find those dots. Oh, there we go. And you're going to have to zoom in over it. So you look, let's see. So in this case, it's really hard to tell because we can't really move in because they are different. Okay, you might need to adjust. Let's do 25, see if that helps. Okay, it does not. So in this case, we're going to have to see the difference, okay, or the ratio. So from here to here, I add 476. we'll subtract 476. From here to here, that's another 476. From here to here, negative 40, subtract 480. And from here to here, subtract 480. Now, they're not exactly the same, okay? Because we know if we take real data, okay, real data is not always gonna follow the trend. Okay, you might have it a little off. We're looking at the whole picture. So if you look at the whole picture, they pretty much constant. It was 476 close to 480. Yes, it is. So therefore we can say linear. Okay, because not all data is going to completely follow the trend. We're looking to see if it comes close. Okay, and it comes very close to being constant. Okay, so we're going to say this one is linear. So now we have to find the equation, okay, which is y equals mx plus b. Okay, so in Desmos, even if you can't see it all, if you come to this, okay, and you do y1 equals m x1 plus b okay, and this needs to be a little straightly. Okay, so if you put this, okay, if you put your data in, even if you cannot see the graph, okay, if you put your table, your data in your table, it will give you that equation, okay? So you see y1, so this will be y equals m, it gives you m. Okay, m is going to be 8.7, okay, x, because that's m, plus your b, which is 18,252.4. And that's going to be your equation, okay? So Desmos will give you the equation, so you don't have to do it by hand, okay? But you're going to have to recognize if it's linear or not by looking at the table and seeing the differences, okay? So, again, it is linear, and my equation is going to be y equals 480.7x plus 18,252.4. Okay, and again, the way you would do it, you would put this in Desmos. Okay, you have to make sure you put the 1 in a little straggly, or it's not going to do it correctly. Okay, and that completes today's lesson. Okay, I know it was a lot. Okay, if you have questions, please let me know. We will do more of this in your homework, and we'll do it in your warm-ups too. Okay, y'all have a good day.